Okay, so this is for period 1. There's been a change to the assessment for 2C. Instead of giving you guys a test, I've decided to have you do a small project. It will be a lot more fun, a lot more useful. You'll get more out of it, and it won't be as boring. You will have until November 2nd to complete the project. It's already been posted to the last item in Module 2. And I'll share my screen, let you know where that is. On my overhead screen, the one you're seeing right now, I'm including the general form of a function where it shows you the location of where the reflection is, and the horizontal shift, and the vertical shift, and at the very bottom, you can see where, excuse me, the new function, y equals 1 over x is called an inverse function or rational function. And we'll talk about that more on Monday, but to shift this, stretch it, reflect it, is no different than with any other function. The horizontal shift happens inside the function. Vertical shift happens outside the function. And the a stretch, in this case, if a were in front of the ratio 1 over x, you could actually simplify it as a over x. So that's how that shows up. You can use the inverse function for the project if you wish. You can also use a circle function. Actually, a circle is not a function, it's a relation. But again, we'll go over how to do that on Monday. I don't want you to just have to explore the web and figure this out on your own. So with that, let's move to where the project is. And well, first let me show you my inspiration for this project. So I got a catalog in the mail yesterday at Pendleton Woolen Mills, and it reminded me of all the math that we have in the real world here, especially design work. These are all transformations of functions, probably absolute value functions. And what I'm asking you guys to do is come up with your own design, but there's some criteria. You can color it using shading. There's some requirements as to the number of functions you use, but this was an inspiration for me to give you a project as opposed to a boring test. So in Canvas, if you scroll down to Unit 2 at the very bottom, you'll see your assessments from 2B, and here it is, Target 2C Final Project, all periods. You can download it, or you can just click on Preview, and it's going to be a digital drawing using Desmos. So these are all the instructions. We'll go through how to sign in. If you haven't created an account, how to share a link to your project. You're welcome to collaborate with others while you're doing this, but no, you're responsible for a final project that is yours. But if you want to work with somebody and help them out on theirs, or you want help on yours, that's fine. But I want individual projects. I want it to be your design, not copying somebody else's, or I want it to be unique. I want everyone's project to be unique. So to meet the standard, these are the requirements. To exceed the standard, these are the requirements. To exceed the standard, you can use brackets to constrain the domain and range. I'll explain how to do that in a moment when we're on Desmos. The rubric is on the second page. And here's some examples of previous work. The student is approaching the standard. There is not enough information here, and to meet the standard, you need to have reflection over at least the X or Y axes. To exceed the standard, that's when you're going to be shading and providing more information, and then it has to have some symmetry across both axes. So how do we get all that stuff done? Well, if we go to Desmos,
like it would technically be possible with the difference here.
you see this screen here. Let me move some stuff here so I can see it. So you have an untitled graph. Let's say you've entered some equations, you're starting to build this, and you want to save it. Click on the untitled graph, give it a name, and click Save. And then as you make changes, you're going to have to keep saving, and then you can actually resave. If you want to make a couple of starts, and you may not be sure as to whether you want to keep one design or go with another, you can save them and always go into these 3 bars and see what you saved in the past. Here's one I started. I've shifted a cubic function and shaded it using inequalities. Know that if you just turn this back into equals, you can get the graphs without the shading. But to exceed the standard, you're going to need some shading. So how do the restrictions play? Well, so we can define for this one, which is the red one, I've restricted it to where my range, my Y values, are only greater than 0, greater than or equal to 0. So it's only going to show the part that's where the Y values are greater than 0. It will not show you the part that's below. If I don't want to restrict it, I can simply get rid of that. But again, to restrict it, you use the curly brackets and the inequality notations. Okay. Let's take a look at what the inverse function looks like. Y equals 1 over x. This is an inverse function. And you can stretch it, dilate it, shift it, just like any other function. Again, to dilate it, notice, let's first talk about the critical points here. Critical points are right here and right here. These are the first points you would plot if you were to graph an inverse function. How you stretch an inverse function is by changing the a value. The a value right now is 1. I can change it to 4. And notice how that dilates it out away from the origin along this line y equals x.
Perfect.
How is that a value related to these points? Well, 2 times 2 is 4. Negative 2 times negative 2 is 4. I can send it out to 3, 3, 3, and negative 3, negative 3 by typing in 9 for my a value. Okay, so a stretch value in terms of the inverse function sends the graph dilated out away from the origin by this distance here is different than the horizontal vertical distance, but the critical point moves to the square root, comma, the square root of that point is the square root of 9, comma, square root of 9. How do we shift it? Well, if I want to shift it, I can shift it inside the function, would be shifting it left and right. Outside the function, We'll be shifting it up or down. No different than any other function that includes an A, H, and K. Okay, so that's the extent of that. To share your graph, you go over to upper right-hand corner, share graph icon here. Click on it, copy the link. You can share it with me, share it with other students, and you can get feedback on your work so far. Okay, I think that's all you need to know for now. If you want to get started on the project, you're welcome to do that this weekend. We will cover target 3A on Monday. Please be on time. I also want to include, for those who are interested, I want to show you how to graph a circle and the dilation of a circle, which ends up giving you an ellipse. A stretch horizontally and vertically of a circle will give you an ellipse.